Chemical and physical weathering. So there's three parts to the weathering and erosion system. It's not just weathering and erosion, but you also have to have the deposition piece. And these are like a vicious cycle. When you have weathering, things are usually going to be moved. When things are moved, they're then going to get put down somewhere. When they're put down somewhere, they're probably going to get broken down and moved and put down, and broken down and moved and put down. So there's this vicious three-part system cycle. So weathering itself is the breakdown of larger rocks into smaller particles known as sediments. Erosion is when those sediments get moved, so they're transported. And deposition is when those sediments get put down, or when sediments are deposited. I know you're not supposed to use the same word in the definition, but basically deposition is these sediments get put down. So there's two different types of weathering. You've got physical weathering and chemical weathering. The first one we're going to talk about is physical, which is also called mechanical weathering. So make sure you write that down, or you kind of put a mental note in. The mechanical weathering and physical weathering, same thing. So what it is the breakdown of smaller rocks or smaller pieces without actually changing the chemical composition of it. So really, if you think about it, and I always use this example every year and it grosses people out a little bit, but if you were to take someone's arm, so say take my arm, and I were to chop it off, okay? The piece of my arm that's flopping around is still made up of the same stuff I am, it's just no longer attached to me. It's the same thing with rocks. If you break a rock, it's still the same type of rock, it's just smaller. So that's all that physical weathering is. It's a big piece of rock gets broken down into smaller pieces can be broken down into even smaller pieces, so on and so forth. So these different forms of physical or mechanical weathering, we're going to talk about those. Then this is the most common, especially in this area. This freezing and thawing, also known as frost action. So what happens is, haven't you ever, when you were a kid, you put a bottle of water in the freezer, and then when you went to take the bottle of water out, like the container is so expanded and is not the shape that it was before? That's because when water freezes, it expands. So what happens is that the water gets into the cracks of these rocks, it freezes outside like it does in the winter time, and that frozen water in the cracks then starts to expand. When it expands, it actually is strong enough to break the rock. And it can break the rock into smaller pieces. It can cause giant cracks down rocks if it happens over and over and over again. When it melts, the process repeats itself because the water becomes liquid, it moves into another crack, it freezes, it expands, and it breaks it. Okay? The best climate for this to happen is in the northeast part of the United States. Actually, it's anywhere where there's fluctuation between cold and warm temperatures, and if there's water. Okay? So this is a good example. There's cracks in the rocks, water gets in the cracks, it freezes and expands, it causes the rocks to break. And you can see this in nature. There's actually a lot of places around here and in the Adirondacks that you can go. You can see rocks that are similar to this. That it looked like it was one big piece, and now it's kind of broken up. That's because the water got in the cracks, expanded, broke it. And this is also how we get those cracks in the road too. Because after a while, when cars and vehicles drive over it and the water gets into all the cracks, it freezes, it expands, and it actually can cause those cracks going all through the road. Okay? Expansion and contraction of rocks. Rocks actually can expand and contract so slightly. They expand when they're heated because the molecules are moving faster, and when they cool, they actually contract. So this usually will happen in deserts where temperature changes drastically. During the day in the desert, you're gonna know that it's very, very hot. Where at nighttime, because there's no moisture in the air, it's going to get very, very cold. So it allows for those drastic fluctuations of temperature. That's going to cause this expansion and contraction in the rocks. This is also another reason why, if you've ever gone over a bridge, and you know how those bridges have the metal strips that kind of lie next to each other? Those metal strips are there, and there's like a small crack. You can almost see either the river or whatever you have underneath you. Those are there because the rock and the blacktop on, or the concrete, whatever it's made out of, and the metal, it all expands and contracts, and it's got to have some wiggle room when it expands and contracts so that it doesn't break it or it doesn't cause it to fall apart. So this is a good example of the cracks that expansion and contraction causes. Okay, abrasion. This one's really interesting because there's abrasion that happens in a lot of places. So what it is the rubbing together of rocks or particles, and they can bang together in a river. They can bang together with wind too. So it causes the rocks to be rounded. And this will happen in deserts, it happens in beaches, it happens in bodies of water, mostly running bodies of water. Your rivers will definitely have rounded rocks. So you can see here in this river, you have rounded rocks. Abrasion is also used as a tool too, where they take and they sandblast things. So what happens is, if you've ever seen, if you've gone under a bridge or like one of those overpasses on the Northway, and you notice how they have all of that like sheeting covering around it, a lot of times what they're doing is they're doing sand abrasion. They have this it's almost like a hose that shoots out sand. It then sucks it up in different areas, and what it'll do is it wears down surfaces to make them smooth or to make them so that they can fix them however they're doing it. Okay, so that's abrasion. Then we actually have living organisms. Living organisms can cause rocks to physically change. What happens is the roots of trees can actually grow in the cracks of rocks and cause them to expand and break. Also, ants and rodents are a big cause, or not a huge cause, but they can break down rocks to be smaller. Ants are really strong, and rodents will use their teeth to grind it on it to cause a rock to get smaller. And they will break over time. It is minimal over time. It's not like an ant is going to eat through a whole entire rock and break it down into sand. But there will be, over time, they do break it down. So you can see here the cracks that are being caused by the roots growing down through the rocks. And then we have exfoliation, which is kind of similar to what you think about when you're like exfoliating your skin. Basically, you're using an abrasive tool, got it, sort of, and it breaks off the surface layer of your skin. In terms of this exfoliation, what happens is water kind of absorbs into the rock a little bit, causes the rock to swell, and then the outer layers can peel off of it. So that's exfoliation, it's the peeling away of the layers. And then pressure unloading. It says when rocks are buried deep in the ground and are under a lot of pressure, what happens is, if you've ever been playing with friends or whoever, and somebody sits on your chest, and they sit on your chest for a couple minutes, and then when they get off, if you feel like you can take the deepest breath that you ever can take, and your chest is just going to expand so much, that's kind of like what pressure unloading is. These layers of rocks underneath have just been pushed down, pushed down, pushed down, pushed down, and then once that layer on top that's been removed, that pressure that's no longer there, those rocks kind of have room to breathe a little bit. Not really breathe, but they are able to expand. And when they start to expand, because there's no pressure holding them down anymore, it's going to cause cracks. It's going to cause the rock to break. This usually happens after glaciers retreat, because glaciers are giant chunks of ice that travel over the surface, and they actually put a lot of pressure on what's underneath. Once those glaciers are gone, that pressure unloading is going to happen. So then we're going to switch to chemical weathering. Chemical weathering is when you have a chemical that breaks down a rock into something different. Okay, it breaks down the rocks into stable minerals or a different chemical. So let's go through some examples. Our first example is oxidation. Oxidation is a fancy word of saying rust. It's a fancy way to say rust. And most of you have seen rust before. You've seen it on cars, you see it on metal that's outside. And what happens is the minerals in the rocks, they react with the oxygen in the air or the oxygen in water. And it can break down and you get rust, which is just an iron oxide. And most of you have seen rust before, but I'll show you a picture because it looks kind of cool. Then we have carbonation. Carbonation is when carbon dioxide and water in the air, they mix, and it becomes carbonic acid. Carbonic acid basically creates acid rain. It's caused from pollution in the air. There used to be significant amounts of acid rain around here in New York State when all of the factories in different parts of Ohio and Michigan and those areas that used to have lots and lots of factories before they put the regulations on their emissions, we had significant amounts of acid rain that actually lowered populations of animals and killed off some animals in some lakes. Acid rain also weathers away gravestones. So headstones used to be made out of marble. Marble is made up of limestone. Limestone has calcite in it. Calcite reacts with acid. So a lot of these headstones have been worn away because of the acid rain. Also, with underground, the water will trickle through and it travels through the rocks and it wears away some of the rocks, like limestone. This is actually how caverns was formed. There were 2 layers of limestone. One was less dense. In fact, the one that was less dense was underneath, and the acid rain and the acidity in the water actually washed that away, created these big caverns at Howe Caverns, which is kind of cool. So this is a headstone that's been worn away from acid rain. This is an obelisk that you can see. The before picture had all of these writings etched in it, and unfortunately after on one side of it that gets exposed to a lot of rain, a lot of acid rain, it's been worn away to a point where you can't see it anymore. You can't see the etchings. Hydrolysis, this is when the rocks will actually absorb water and the minerals that are inside of it can actually get dissolved away. Like halite and calcite are easily dissolvable minerals. They can get dissolved away by the water. They travel through with the water once the water travels out of it, and it changes the rock. So factors that affect the rate of weathering, how fast your weathering is going to happen. Climate. If it is hot and humid, you're going to have a lot of chemical weathering. Hot and humid weather causes lots of chemical weathering, okay? This you can actually see here because the tops of these mountains and the tops of these hills are pretty rounded. The rounded actually shows there's lots of weathering going on here. So it's gonna be hot and humid in this area. There's also a lot of precipitation. A lot of times when you have a lot of water there too, it means there's gonna be a lot of weathering. Oh no, I didn't mean to do that. Okay, so what is the best environment for chemical weathering? It's going to be anywhere that's hot and humid. Best example in the United States, Florida. Rains almost every day. It's hot and humid most of the year. It's going to have a lot of chemical weathering happening there. Around here, we're going to have a lot of high frost action. A lot of that fluctuation between temperatures, especially in the winter time, causing for that water to expand in rocks. That's going to cause a lot of physical weathering. We also do get chemical weathering too in the summertime because we do reach those warmer temperatures and we have lots of rainwater. Okay, the size of the particle is going to affect how fast it weathers. Okay, the smaller the particle, there's more surface area and lots of those particles, they're going to get worn away faster. This is that surface area idea. So when you have one big unit, it's basically 24 square units, but when you start breaking it down, you're exposing more of the surface of it, it's going to break them down much faster. What it's made of. So the mineral composition is going to affect of how it's going to break down. Some minerals you know are much harder than other minerals. So like quartz versus marble. Quartz is a really strong mineral. Marble is a rock that has calcite in it. Calcite, we know, breaks down easily with acid, and it can be easily dissolved with water over time. So which is more resistant? Quartz will be, because it's a harder mineral. It's more resistant. This is also why over time they've decided to make headstones out of granite versus marble. Marble, we said, breaks down really easily, but these granite headstones are made out of harder mineral content, so they don't break down as easily, and they hold up a lot better. They've also come up with a new chemical over the top of it too to keep it from shiny, or keeps it shiny and makes it look nice for longer periods of time. Also, the things that affect weathering is the amount of time that it is exposed. The more time it's outside and the more time it's exposed to weathering type things, of course, the more it's going to get weathered. So what happens to a rock once it's been weathered? Well, it turns into a sediment, or it's considered to be a sediment. It breaks down into these sediments. They're classified by their size. You have boulders, cobbles, pebbles, sand, silt, and clay. Biggest down to the smallest. Soil also comes from those sediments, and it's a result of weathered rock, which is a mix of minerals and particles, but soil has to have this organic material, air, and water kind of mixed into it in order for it to be considered a soil. And this is just a cool picture of stalactites hanging from a ceiling. Remember that those are just left over from the water trickling through the rock, and that's the mineral that gets left over. So, kind of cool.